Today we're looking at section 2.2, addition of real numbers. Adding real numbers using the number line or addition rules, and we're using them in real life problems beginning on page 72 in the textbook. Example number 1 says adding 3 real numbers. Use a number line to add -2, -7, and +10. -2, -7, and +10. So notice from -2, the first number you start at is the first one given. Start at -2. You're adding negative, notice that's 2 units to the left of 0. 2 units to the left of 0. When you're adding -7, since it's a negative value, you're moving to the left 7 times. So left 1, 2, 3, 4, 5, 6, 7. You get to -9. Then you're adding the last number, +10. That means move 10 times to the right. So from -9 now, that's where we are, we're going to move 10 times to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we end up at +1. That is using a number line. And again, those are your steps. To add, start at -2 because that's the first number given. To add 7, move 7, -7, move 7 units left. If it's negative, you're moving left. To add +10, move 10 units to the right. You end up at +1. Rules of addition say to add 2 numbers with the same sign, add their absolute values. So we have 2 plus 2, for example. Both of those are +2's. You add the absolute value of each of them. The absolute value of 2 plus the absolute value of 2 is the absolute value of 4, which is 4. If you do the same thing but with negative values, notice again, they're both the same sign. The absolute value of -2 plus the absolute value of -2 gives you the same number 4 that we just got. However, the second step is to keep the common sign. They were both negative for that second example in red. Since they're both negative, you would keep that common sign, -4. Here's an example. -4 plus -5, same sign. Add the absolute values, 4 and 5, and you get 9. Keep that common sign, which was negative, and attach it to the 9 to create a negative sign. If they are opposite signs, this is where people start getting messed up. Subtract the smaller one from the larger one. And what we mean by smaller from larger, the smaller absolute value from the larger one. So 1 plus a -9. -9 is the larger absolute value. So you would take each of their absolute values and subtract the absolute value of -1 minus the absolute value of 1. So that means 9 minus 1 would give you the number 8 in that case. And then you keep the sign of the larger absolute value. And here's an example down here. 3 plus -9. The larger absolute value in this case is 9. So 9 minus 3 gives you the number 6. And since 9 is the higher absolute value, its sign of negative goes in front of the 6. Had the absolute values, the higher one been positive, it would be a positive number. Its properties of addition. One of them is the commutative property. If all that changes is the order, then it's commuting. Think of people who commute to work. These numbers are just commuting to a different part of the problem. A plus B is in that order, it becomes B plus A. The example is 3 plus -2 is the same thing as -2 plus 3. Notice the only thing that changed was the order. You'll still come up with the same solution. The associative property is how the numbers associate with each other. A plus B plus C, when A and B are in parentheses first, is the same thing as A plus B plus C in parentheses. So -5 plus 6 plus 2, where -5 and 6 are in parentheses, is the same thing as -5 plus 6 plus 2 in parentheses. That's just they're associating in a different order. The identity property, and what we'll get to eventually, will be the inverse property. The identity property and the inverse property get people confused. The identity property is whatever it is to start, it remains the same. So if you look at A plus 0, it begins as A, and it remains as A at the end, or at the end it's still A. So A plus 0 And when we get into multiplication, you'll understand why I made that comment. Negative 4 plus 0 is equal to negative 4. Its identity remained unchanged. The property of 0 says that when you add its opposite to it, and this is what will come into the inverse operation, it becomes 0. So a plus negative a is 0, or 5 plus negative 5 equals 0. That's how you cancel numbers out. So don't get confused between the identity property and the property of 0. Identity property, it stays the same. The property of 0 makes it turn into 0. Finding a sum says 2 plus 3 plus 4 plus 2.3 plus 4.7 plus 1.2. Using the associative property, you could add 2.3 and 4.7. The reason that is easier is because 3 and 7 we know are complements of each other, so we get to the number 10. So 4 plus 2 is 6, plus another one is 7, plus the last term in the expression 1.2. So 7 plus 1.2 would give you 8.2. The same thing with B. Negative 2/3 plus 6 plus 2/3 equals 6 plus negative 2/3 plus 2/3. Notice all that happened was that they commuted. Instead of negative 2.2 over 3 being first, 6 being second, and 2/3 being third, 6 became first, negative 2/3 became second, and 2/3 became third. The reason that was done is because you can see that negative 2/3 and positive 2/3 are opposites of each other, or you can use the property of 0. So when you put those two together, you get the number 0. And then 6 plus 0, the identity property, says that it's equal to 6. Anytime you can cancel things out in a problem, it's a good idea to do so, just like that. Then we have a checkpoint, 2 problems. It says 1.2 plus negative 8 plus 2.8. Now, if you use the commutative property here, it makes sense because you can see 0.2 and 0.8, those are complements of each other. So what you want to do is 1.2 plus 2.8 plus negative 8. And again, we did it in that order to where we can put 8. Okay, so we did that because we have complements 0.8 and 0.2. That's going to get us to 10. So 10 will get us to 2 plus 1 is 3, plus 1 more because of the 10th will give us 4, or 4.0, plus a negative 8. And all we did for that step was we used the commutative property. Then 4 plus a negative 8. Now we have opposite signs, 4 and negative 8. So you subtract the higher absolute value, you subtract the lower absolute value from it. So the absolute value of negative 8 minus the absolute value of 4. The absolute value of negative 8 is 8, minus the absolute value of 4 is 4. That'll give us 4. And then once you have the number 4, you keep the sign of the higher absolute value. 8 is the higher absolute value. Its sign was negative, so you keep it as negative 4. For the second one, 3/4 plus 3 plus negative 3/4. Again, use a commutative property because 3/4 and negative 3/4 will get you to the property of 0. So 3/4 plus negative 3/4, all we did was reordered it or commuted it to another part of the problem, plus 3. And again, it's the same commutative property. This will give us 0 when we put these together. And then the identity problem, or the identity property, 0 plus 3, will give us 3. And that's just the identity property. Section 2.3 is subtraction of real numbers. Subtracting real numbers using the subtracting rule, and we're solving real life problems. Terms are an expression written as a sum. The parts are added. The parts that are added are terms of the expression. 2.3, subtraction of real numbers. We're using subtraction rule. We're going to use them in real life problems. We have a couple of definitions. When a term is when an expression is written as a sum, that means when you're adding parts up, the parts that are added are the terms of the expression. So, for instance, 2 plus 3 plus 1, those would be your terms, 2, 3, and 1. X plus 2 plus 1, your terms would be X, 2, and 1. So the things that are adding together are your terms. The subtraction rule says to subtract B from A, add the opposite of B to A. The only reason we're using this thing called the subtraction rule is to where we can follow the same rules that you use for addition. So instead of A minus B, it's A plus a negative B. So you're changing subtraction into addition. Once you get comfortable with this, I don't expect you to change it into addition every time. Subtraction is fine. But you have to understand that subtraction is the same thing as a negative number, which is the same thing as subtraction. They mean the exact same thing. So 3 minus 5 is the same thing as 3 plus a negative 5. The result is the difference of A and B. Example number 1 is evaluating the expression negative 5 minus 3 minus negative 1 minus 5. So we're just changing all of these minuses into addition signs, but you have to add the opposite. So instead of negative 5 minus 3, it becomes negative 5 plus a negative 3. Instead of saying minus a negative 1, it's plus a positive 1 because it's the opposite. It's not plus a negative, it's plus the opposite. Instead of saying minus 5, it's saying plus a negative 5. So notice all of the subtraction became addition, but it is adding by the opposite. So negative 5 plus a negative 3 is negative 8. Negative 8 plus 1 plus negative 5, when you add negative 3 to it, negative 8 plus 1 is negative 7, and negative 7 plus a negative 5 is negative 12. We're just using the left to right rule because, and please excuse my dear, when we get to the Aunt Sally part, remember you don't skip over one to do the other one. You leave those together, addition and subtraction. Example number 2 is finding the terms of an expression. So when everything's being added up, write the terms. Combine the stuff you can and write the terms. So find the terms of negative 3 minus 8x minus y. So if you use a subtraction rule, that means you're going to add all the opposite numbers. Negative 3 is going to stay the same, but instead of saying minus 8x, it's going to say plus a negative 8x. Instead of saying minus y, it's going to say plus a negative y. Another way for you to identify the terms, if you just go right back to the beginning, is to say that the sign in front of it is the one that it goes with. So negative goes with 3, negative goes with 8x, and negative goes with y. So notice it's not 3 as a term, it's negative 3. It's not 8x as a term, it's negative 8x, and it's not y, it's negative y. Again, subtraction is the same thing as a negative number. It's just like adding a negative number. So 1 minus 2 minus a negative 3, if you use a subtraction rule, would become 1 plus a negative 2. Again, do this for now. I don't expect you to do this forever. Plus, and it's the opposite of negative 3, which would be a positive 3. And all that is, if we say in what we did right there, we're just using the subtraction rule. So 1 plus a negative 2, those are opposite terms. So you take the higher absolute value, which is 2, and you subtract 1 from it, and you get 1. But since 2's value is a higher one, it's a negative value, it'll be negative 1 plus 3. And all that is adding. And then the same step that we just did, negative 1 plus 3, subtract the absolute values, the higher one from the lower one. 3 minus 1 is 2. And since 3's sign is positive, it's a positive 2. Find the terms of negative 8 minus 7x. Again, if you use a subtraction rule, it'll be negative 8 plus a negative 7x. So when we look at the terms, it's negative 8, and that's just the subtraction rule again, and negative 7x. So negative 8 and negative 7x. Again, an easy way to do this is to just say the sign that's attached to it, the sign in front, is the term that goes with it, the sign that's in front. And then we evaluate the function, just like the bell where it says evaluate y equals 2x minus 3 for the values negative 2, negative 1, 0, and 1. So instead of doing positive 2, we got negative 2 in there. So your input is negative 2. You plug it in place of x. 2 times negative 2 is negative 4. Just kind of do the intermediate step out here on the side. Negative 4 minus 3 gives you negative 7. That's the hardest one because it's a value 2. The negative 1 and the 0 are pretty easy. 2 times negative 1 is negative 2. And negative 2, just like the last one, negative 2 minus 3 is negative 5. When you plug in 0, substitute 0, it's easy. Anything times 0 is 0. And 0 minus 3 is negative 3. Then finally, when you plug in 1, 2 times 1 is 2. And 2 minus 3 is negative 1. Then it says describe the pattern. Every time x increases by 1, we go from negative 1 to negative 2 to negative 1 to 0 to 1 to 2 to 3 to 4 to keep going. The y value increases by 2. Negative 7 becomes negative 5, negative 3, negative 1, and so on and so forth.